tutorial for you guys on graphing inequalities on a number line. So let's get started. One of the first things you're going to need to do is recall inequalities, all right? So you need to know your less than or equal to, your greater than or equal to, your less than, and your greater than symbols, or your main inequalities we'll be working with, okay? Now, in order to graph these on the number line, you need to understand that when it's less than or greater than and includes equal to, like these two symbols up here, that means that that value is included, okay? It's actually included as a possible solution because it might actually be equal to it. And because of that, when you graph these on a number line, you're going to graph it with starting with a solid circle, all right? You're going to need to fill that circle in to show that that is a possible included value, all right? Now, what if it's not included, all right? Well, if it's not included, if it's just less than or greater than, then you're still going to circle the value, but you're not going to fill it in. You're going to leave it as a hole in the graph. It's going to be an empty circle, okay? So let's walk through some examples and I can show you a little bit more of what I'm talking about. All right, so example A, 4 is greater than X. All right, that's old stuff. We've done that before. 4 is greater than X. All right, so the first thing I want to do is identify 4 on my number line. I'm just going to start off by creating a circle around that value. All right, so there's 4 that I circled on the number line, and right now it's not filled in. All right, and to tell myself whether I need to fill that in or not, I'm going to look at my symbols. So right now we're looking with greater than. So 4 is greater than X, and that means that the value is not included, so I'm going to leave my circle open, okay? Now I need to ask myself, am I shading in all the possible values to the right or all the possible values to the left, okay? And that's when you can just pick a value and see if it makes your inequality true, to ask yourself if your answer makes sense, all right? You don't have to rush through this. It's okay to take your time and think about it. All right, so that being said, let's see. If I pick a number to the left, a number that's less than 4, like 3, 4 is greater than 3. Well, that's a true statement. 4 is certainly greater than 3. So I'm going to lean with, I need to shade in all the values to the left, all right? But let's see what happens if I picked a number to the right instead. What if I picked 5? Is 4 greater than 5? No, 4 is certainly not greater than 5. It's to the left of 5 on the number line, which means that it's less than 5. So I know that is not a correct solution. I'm going to go ahead and shade in all of my values to the left of 4 on the number line. And as you will also run into, you're going to run out of space on your number line just like I will. Now that doesn't mean that we stop including the numbers that are less than 4. It just means that we're going to put an arrow to show that our number line continues on to include all of the values that are less than 4. All right? And I can pick any number in my shaded area and it should create a true solution. All right? So let's see. -2. Is 4 greater than -2? Yeah, that works. Okay. 0. Is 4 greater than 0? Yes, that works. So pick numbers and ask yourself, does my answer make sense? Okay. All right. Next example, letter B. 3 is less than or equal to X. 3 is less than or equal to X. Okay. So where's 3? Right here. Pick that value right there. And this one, less than or equal to, means that 3 is a possible solution. It is an included value. So because of that, I need to make sure that my 3 is also shaded in. So let's make room to shade this in. Okay, so now I need to figure out, where are my possible solutions? Are they to the left of 3 or to the right of 3? All right, so 3 is less than or equal to X. I'm just always tend to go with the left and the right, just like how we read. So if I pick 2 first, 3 is less than or equal to 2. That's not true, right? 3 is not less than or equal to 2. It's certainly not equal to 2, and it's not less than 2 either, so that is not a possible solution. So I'm going to pick a value on the right now. 4 instead. So 3 is less than or equal to 4. That is true. 3 might not be equal to 4, but it is certainly less than 4. Okay? Let's see if I picked another value. 6. 3 is less than or equal to 6. That still rings true. I'm going to go ahead and shade in all the values to the right of 3 on the number line as a possible solution. And again, when we run out of space, we're just going to put an arrow to show that it continues on to include all the values that are greater than or equal to 3. And notice that even if I read my inequality, backwards, I still have the same exact values or same exact answer, right? If I said x is greater than or equal to 3, x is greater than or equal to 3. Oh, here's all the values that are greater than x, okay? So you can read an inequality in either direction as long as you make sure that you're always saying the value greater than is the value where the opening is pointing towards, okay? So -1 is greater than or equal to x. -1 is greater than or equal to x. Okay, so -1 is right here. And I already want to rush and go ahead and fill that in because I know that if it says or equal to, that means that value is included. So I'm going to go ahead and fill in -1 because it is a possible solution here. All right, now that being said, I need to figure out, am I shading the values to the left of -1 or am I shading the values to the right of -1? Well, let's pick some values and see if our answers make sense. Is -1 greater than or equal to -2? Well, it might not be equal to -2, but -1 is certainly greater than it. Remember, the numbers that are greater are always on the right, okay? Our number line increases from least to greatest, starting from the left, moving to the right. So -1 is in fact greater than -2 because it's closer to 0 on the number line, all right? So that is true. Let's pick another value to the left. -3. Is -1 greater than or equal to -3? Well, again, -1 might not be equal to -3, but it is greater than -3. So -3 is also a solution that makes that inequality true. If I were to pick a value to the right, like say I picked, I don't know, +1, is -1 greater than or equal to +1? Well, like we know, it's not greater than, it's not greater than +1, and it's also not equal to +1. So this is a false statement. Same as if I had chose another value over here, like 3. Is -1 greater than or equal to 3? It's not greater than 3. It's not equal to 3. It's not a possible solution. So I'm going to go ahead and shade in all the values to the left because those are where my possible solutions lie that make this inequality true. And when I run out of space, I just go forth and make that arrow. All right. -1 is greater than or equal to -4. Well, -1 is greater than -4, so that creates a true statement for inequality. All right, so that's it. That's our quick tutorial on graphing inequalities on a number line. And stay put. You're going to find a video coming up soon for graphing compound inequalities on a number line. All right? Have a good evening. Bye.